Good day, everyone, my dear students. My name is Henry Unogu. I am a biochemist, and I'll be coming up with series of videos on this platform in chemistry, biology, and other sciences. And of course, after the video plays, you're very free to send in your comments, your questions, and trust me, those questions will be answered. Now, today I will take up chemistry, and the topic we'll be looking at is chemical equilibrium. Now, if you pick up your Oxford Advanced Learners Dictionary, equilibrium simply means balance. Balance. But here, under chemistry, our chemical equilibrium is broadly classified into two. We have the static equilibrium and we have the dynamic equilibrium. Now, we will not lay much emphasis on the static equilibrium. Of course, you know from your youth, when you were quite younger, if you see your balance seesaw, where you have two different individuals sitting, it will be on a balance scale when you have equal weight on both sides with a pivot support. Like I said, we're not going to spend time on static equilibrium. Now, our interest will lie on dynamic equilibrium. What is dynamic equilibrium? Now, let's pick up the element bromine, for example. We all know that at standard temperature and pressure, bromine can exist as a liquid and as a gas. We have bromine liquid and bromine gas. Now, what do you think will happen? Look at this. Remember, we have an open and a closed environment. Now, the open environment means once heating takes place and a gas is evolved, is allowed to be liberated in the atmosphere. That means the gas that is given off travels out. So there is no way you have a forward and a backward reaction. Meaning that once products are formed, they cannot reform reactants. Now, but in a closed circuit, in a closed environment, what you have is upon heating, when gases are given off, they are not allowed to travel out of the tube. So if I have a test tube and I have a test tube cocked, I have it cocked, and I have bromine and I heat. Now, bromine liquid, upon heating, remember, is converted to bromine gas. If I allow this bromine gas to condense, it will be converted back to bromine liquid. Now, everything is happening in this test tube. That means the process of evaporation, that is the conversion of bromine liquid to bromine gas, and the condensation process, that's the reconversion of bromine gas to bromine liquid, occurs at the same time. Of course, the total mass of both reactant and product will remain equal. Now, such tube, we refer to it as a closed tube because the gas is not allowed to be liberated. Now, that is what we talk about when we talk about dynamic equilibrium. It can happen with bromine, it can happen with any other substance that can exist in two states. Now, a scientist called Le Chatelier came up with his theory, to explain chemical equilibrium. And I remember some of you will find this definition pretty terrible to fix in your cerebrum. Remember that Le Chatelier states that if an external constraint, such as a change in temperature, a change in pressure, or a change in concentration, is imposed on a chemical system at equilibrium, the equilibrium will do what? Will shift so as to annul or neutralize the effect of the constraint. Now, what they will not teach you is what is the implication of this theory. What is Le Chatelier trying to state? Now, let me bring it down so that you understand. Let's look at an individual. Oh, I am in a good state. Let me use myself as an example. I am seated right here. What do you think will happen? My system is at equilibrium. Take note. Now, what do you think will happen when I ingest rotten food? Let's say one eba that has been left for days. And of course, you see those mucus growing on it. And I take it, I throw it in my mouth, I ingest it. Something will happen. I will start noticing an intestinal upset. Why? Because an external constraint has been introduced in a system that was initially at equilibrium. Now, that external constraint, remember, was that spoiled eba, which I introduced rather into my system. Now, once I do that, because that is an external constraint which is going to affect my system that was initially at equilibrium, what my system will do will be what? To look for a way to bring out or to throw away, to bring back that external constraint, to remove it from the system. Now, if I ingest that, you'll notice I might decide to start throwing up or whatever. Now, that process of throwing up is the process where my system is trying to give back that external constraint, to remove it from the system so that I can return to my original form of equilibrium. This is just a biological explanation of what Le Chatelier is trying to state. Now remember, he told us that there are three factors that are responsible. He was looking at the change in temperature, a change in pressure, and a change in concentration. Now, we're not going to rush this. In my next video, what I'm going to do is I will explain how do these factors affect the state of equilibrium. Remember, give in your comments, your questions, and we'll answer. Thank you very much.